Okay, so Sree Ganesan is from Habana Labs. She's the head of software products. She's been working along a pretty diverse global team to deliver a state-of-the-art deep learning capabilities based on Habana's Synapse AI software suite. So previously, she was engineering director in Intel's AI products group, where she was responsible for AI software strategy and deep learning framework integration for Nirvana, NNP AI accelerator family. Ms. Ganesan joined Intel in 2001 and has held a variety of technical and management roles in software, engineering, from VLSI CAD to SoC design methodology. Ms. Ganesan received a bachelor's degree in electrical engineering from IIT in Madras and a PhD in computer engineering from the University of Cincinnati in Ohio. Ms. Ganesan will be presenting on making deep learning more accessible to developers. And then I'd also point out that she will be, again, joining us at 11:30 for the panel discussion about productivity and performance boosters for data scientists and developers, where she'll be the moderator. So with that, I'd like to welcome Sree to join us at the podium.
Thank you so much. Great. Hi, everyone. Thank you for joining us in person today. I'm really excited to be here talking to you about making deep learning more accessible to developers. I put that easy button over there because if you know, like a decade ago when I was I've been working with developers for a very long time. And long ago, we were introducing innovative technologies for design automation tools, and it was a challenge for our developers. So I used to have this little easy button on my desk and say, hey, I acknowledge your problem. I realize we're introducing new things and there's a lot changing on you and you want to focus on your logic design and your VLSI design, and the tools shouldn't be in your way. And so every time we acknowledged it and solved the problem. So I figured it was similar today with this deep learning space that I'm in. With the products we're offering. So I wanted to acknowledge, put that easy button out there, and hopefully by the end of this talk, you'll say, I can hit that easy button. So I'll start off with a few trends. We'll talk about what's happening in the why I'm focusing on deep learning first. So first thing is that this market is projected to grow significantly in the near term, in the next couple of years. It's nearly 5x by 2025. A third of the data center servers that are shipped in 26 will be running deep learning workloads. Deep learning will account for a lot of the cloud workloads as well. And training is going to be a big portion of what folks are going to be doing in terms of deep learning. So what's driving this explosive growth in deep learning training? So first is, and what David mentioned is AI is in everything and it's enhancing everything. A lot of organizations, private sector, public sector, are basically trying to leverage AI to bring in reap the advantages and make their business applications smarter and solve their business problems. And as they're doing this, they're accumulating a lot of data sets. These data sets are growing larger. Their models are getting bigger and more complex. They're running a lot of iterations. I have a few data points here. Recent IDC study that talked to AI/ML practitioners, 74% of them say they're running 5 to 10 iterations of training. 50% of them are saying they're retraining their models weekly or even more often. In the crowd that's doing it more often, 26% are retraining it daily or hourly. So it's very obvious where the growth in deep learning training cycles will be. The other trend I want to point out is typically the accelerators associated with AI and ML and deep learning have been GPUs, but there has been a growth in this accelerator market. There are special purpose ASICs that have come out, which are built to solve problems in the AI, ML, deep learning space. And they are more efficient than some of the general purpose compute like CPUs or GPUs. So this trend is here to stay. That introduces yet another vector that we have to acknowledge. And lastly, the most important trend that 56% of the respondents of that same IDC study indicated cost is one of the most significant hurdles that they have in terms of implementing AI solutions. So as an industry, acknowledging all of these trends, it's important to find solutions that help developers overcome these barriers and get to actually the solutions which enable them to deliver value to their businesses. So the main things I think in terms of why now I've kind of positioned why deep learning is the important piece, and now how do we make it more accessible to developers. There are three vectors here. One is affordability, that's addressing the cost challenge we have, accessibility. You need to make both the hardware easily accessible and the software easily accessible, so it can be one or the other. And the last part is education, developer education, making sure that they understand the choices available to them, they understand how to use them effectively and be productive with their work. So I'm going to talk a little bit using Habana's product as an example, and what we are trying to do in terms of addressing these vectors and making deep learning more accessible to developers. So this is our Gaudi training platform. It's purpose-built. It's one of those ASICs, and it's for training efficiency, for usability, for scale. It's built from the ground up for that. So what is different about the Gaudi AI processor? First, that it actually has a heterogeneous compute architecture designed for solving deep learning problems and optimizing those neural networks that run on the device. It has a purpose-built GEM engine for matrix multiplication. It has a cluster of TPCs that are tensor processing cores, which will accelerate the element-wise and nonlinear operations. We've got a software managed memory, we've got local memory, SRAM, HBMs, but as a developer, you don't worry about it. It's managed by our software stack. And the last but most unique feature of Gaudi is the fact that we have multiple 100 gigabit Ethernet RoCE ports that are integrated on chip. What this does is allows you to get very significant scaling efficiency. Now we know that training doesn't run on a single card. It's usually run on multiple devices, multiple servers. So distributed training is a very important piece of enabling developers be effective with making optimal use of their compute and their time. So that's where the scaling efficiency comes in. The second piece is that we're not using discrete devices. By integrating that NIC on die, we have actually reduced the number of discrete components. It saves cost. And that's the part of the cost savings that goes back to you as the end users. And the other thing I want to point out is the industry standard. That protocol is just Ethernet, where you get a lot of flexibility. You're not locked into any vendor's proprietary interfaces. You can basically build out your servers, your cluster, by simply using Ethernet switches and connecting the Gaudi servers to them, because you don't need anything proprietary for it. The other piece, the picture on the right, showing you that we're still fans of the industry ecosystem, that's the Gaudi card, and it's in the OCP OAM form factor, which is another industry standard. So we have two generations, Gaudi first gen and second gen. Second gen was just launched in May of this year. First gen is a 16 nanometer product. It has, you can see that in terms of the compute, memory, networking, there's a lot more of them in the second generation versus the first generations. So we had 8 TPCs in the first gen, 24 TPCs in the second gen. We've added a media engine there. We've added new data type like FP8. On the memory, we've actually increased the HBM size from 32 gigabytes of HBM to 96 gigabytes of HBM2 memory and doubled the memory bandwidth. And there's also more SRAM on die. So you get to do a lot more with Gaudi 2 than you could with the first gen. In terms of networking, I mentioned that we have multiple ports. So on the first generation, we have 10 ports of 100 gigabit Ethernet that's integrated on die. In the second gen, 24 ports. So you get even more scalability with Gaudi 2. In terms of TDP, first gen is 350 watt, second gen is a 600 watt air-cooled part. So generally, like Gaudi 2 builds on the same architectural efficiency of Gaudi. It's just a lot more of the compute, memory, and networking that's on die. So the first generation is available both on in the cloud and on premises. So on the cloud, you can go to AWS, the EC2 DL1 instance. is powered by Gaudi. It actually leads in terms of AWS training efficiency. You can get, according to AWS, up to 40% better price performance than the latest GPU-based instances. We have also worked with Supermicro to provide commercial servers. This is the X12 Gaudi server that's available. We're partnering with other storage vendors like DDN to build out reference configurations so you can go install your on-premise systems with both the storage, network, and computing all optimized already. So I want to address, so one part is accessibility, so being easily accessible in the cloud, also available on-premise. You can do a hybrid if you'd like. And the other piece is the affordability. I talked about the Gaudi. One of the most significant value propositions you get is cost savings. I'm using the DL1 instance pricing here to show you some cost savings for vision and language models using ResNet 50 and BERT Large as proxy models. You'll see on the ResNet 50, we compared it against the P3 and P4D instances versus DL1. You get 40 to 45% on ResNet 50 compared to the A100 instances, over 70% when compared to V100. And similarly for BERT Large, you'll see two charts there. There are two phases in training, phase 1 and phase 2. The training regime is different, so the performance and the cost performance behaviors are different. So we're trying to show you a variety in terms of what it looks like in terms of cost savings. So you still get significant cost savings with when the training regime varies. And these numbers are still kind of holding true across a variety of workloads that many of our customers are benchmarking, and they're seeing easily 60-70% cost savings against V100 and sometimes more than 40% versus the A100. So Gaudi 2, in addition to the cost efficiency, also offers leadership performance. Here you'll see that, again, with ResNet and BERT, you get nearly 2x better throughput compared to A100 80 gig servers. So as a data scientist, you get to train your models faster and take advantage of the cost efficiency that Gaudi will offer you. So I talked about, obviously we have a large number of instances in the cloud. In terms of the most, like the publicly announced large cluster, I want to talk about the San Diego Supercomputing Center, where we have the Voyager cluster that was opened up, and it's in testbed phase now, where researchers across different universities and institutions can come in and start working on the science and engineering problems that they're trying to solve using deep learning, and they'll take advantage of this cluster. It has 42 Gaudi servers, that's about 334 Gaudi cards that are installed, and it also has our inference cards available in this system as well. And it's built using the Supermicro X12 servers. So all this is about the hardware, the architecture, how it offers efficiency by actually being designed to solve deep learning training problems. But without having a software stack that's also designed similarly to optimize performance for this for the hardware, for Gaudi, and making it easy for end user to take advantage of it. It's just a piece of hardware, you're going to struggle with it, you need to put it in the hands of those developers. So this is part of the accessibility story. How do we make our software stack more accessible? So Synapse AI is our software stack. The stuff in blue is all of our different components that interact with each other. We have a framework integration layer that hooks into the TensorFlow and PyTorch frameworks. These are the most popular frameworks that developers are using for deep learning workloads. And we basically use the publicly available versions and integrate Synapse AI into it. So then we extract the computation graph from the framework, and then it gets, we extract the subgraph that Gaudi can accelerate, and then basically our graph compiler and runtime and communication libraries, all of these are going to be optimizing that neural network topology and executing it on the Gaudi device. I also want to point out that we have a highly optimized, performance-optimized kernel library that comes with our software stack, and it allows you to get the best performance with all these different operators that are executing on the device. And in addition, we acknowledge that there is a class of what I call ninja developers who want to write their own custom kernels and extract every last ounce of performance. For them, we actually offer a way to program those TPC kernels, and then they can register those custom kernels, and Synapse AI's software stack will basically take advantage of their kernels along with Habana's kernel library. At the end of the day, we want developers to work in their favorite level of abstraction, which is at the framework level. In TensorFlow and PyTorch, we want to have our code work as easily as possible, just out of the box, with very, very limited code changes to enable Gaudi. So all of the other pieces are very specific to our Gaudi architecture, and Habana will take care of making sure that it's optimized and available for developers to just use as is. But the story doesn't stop with us building out our solutions. We've got the reality is there is a very large ecosystem of software tools, developer tools, model libraries, and MLOps solutions. There's a lot of this going on in the ecosystem. There's a lot of ideas that are out there that get turned into open source software, and developers start adopting it. So there's a lot of movement, and we want to keep up with that so that we can meet the developers where they are. Part of this effort, we've started off some work with a few partners. Hugging Face needs no introduction. Synapse AI is now upstreamed into the Hugging Face Transformer library, so you can start using the Hugging Face Transformer trainer with Synapse AI and start running it very easily with Gaudi. Instead of using the Transformer core library class, you will just use the Gaudi trainer class, and the Hugging Face team has made it super simple in terms of keeping the interfaces very, very similar to what Transformer users are familiar with. And we worked with the Lightning team on integrating Synapse AI into PyTorch Lightning. Now, Lightning is a lightweight framework on top of PyTorch, and we're seeing a lot of developers gravitate to Lightning. This is basically offering a lot of abstractions and making it very easy for developers, and they're not worried about low-level code that they write in PyTorch. So this is, again, more productivity and taking advantage of the cost efficiency that Gaudi offers. Converge.io is an MLOps solution where this is solving a different type of problem that developers have in terms of experiment management, version control, hyperparameter tuning. How do I kind of do all of this work and keep track of all of it, and then go deploy it into production, keep monitoring what I've deployed into production, and Converge provides that solution both with on-premise and in the cloud. So you can try it on-premise, you can cloud burst. It's hardware agnostic. Most of these platforms support multiple accelerators, so it's very convenient, and you can just get started very easily. There are several other partners that we're working with, which we haven't announced yet and will be coming soon. So the other piece, in addition to working with partners, in addition to building out an optimized, easy-to-use stack, we also wanted to make it easy for developers to have a lot of materials so they can just get started on their own. The existing ecosystem has a lot of solutions out there and a lot of knowledge out there as part of making this technology available to them so they can get started on their own. We've built our developer site with particularly developers in mind. There are a lot of resources, videos, tutorials. We've got reference models. We've got 40 plus actually right now on our GitHub, publicly available, with TensorFlow and PyTorch models, which you can get started with immediately. A lot of our developer community actually appreciates this because it's very easy to get started with Gaudi once you have these popular models as the baseline. We have other examples of how do you program your TPC. We've got our developer forum. We've got whatever format that developers like to consume information, whether it's nuggets of small tutorials, or it's like the entire model, or just documentation or video. Like, we're trying to put material out there that they can consume in the manner that they choose and make it easy for them. So the customers that we have and our end users are actually using Gaudi for a variety of use cases, mostly in computer vision and NLP, with customers using them for defect detection, smart checkout in retail, It's across a lot of verticals, across the AV space, where we've talked about Mobileye being one of our key customers, using it for 2D and 3D object detection segmentation, medical imaging use cases. So, and NLP cuts across many verticals, and there's a lot of use cases there as well. So this is, again, going back to the theme that there are these core models and capabilities, and it's a horizontal capability that's kind of getting infused into a lot of verticals, and many customers are now taking advantage of Gaudi's cost efficiency and applying them in many use cases. And I want to also talk about the third piece. We've talked about affordability, we've talked about hardware accessibility, software accessibility. I want to talk about the developer education and outreach a little bit more. We are also, in addition to all of that training and all of that material, which is more like consume it yourself, we're providing a lot of immersive engagement. So there is free and easy access to hands-on workshops, hackathons, developer jams, so you can actually get your feet wet and get with folks and mentors who can work with you. There's obviously all the technical resources that are available. And we're also building out online training courses, so we'll keep doing more. We just announced our partnership program for research institutions and academia. So we're going to continue to build out our education and outreach for developers. This is another key aspect in making sure data scientists and developers understand the choices available to them and are able to take advantage of the best platform for their needs. So I talked about these three vectors, hopefully using Habana's work as an example. I think it applies in many other scenarios, because these trends are here to stay. I hope that I've convinced you can that it's easy, but there's a lot more. We're just starting our journey, and I would invite you to join us on this journey. I want to leave you with this fun quote from an ML developer from Mobileye that worked with us, who really thought that Gaudi means fun, and he had really a lot of fun. And I've put in a few resources here for you to take a look. You can check out our website, our developer site. I invite you to try the DL1 instances. You can reach out with questions or anything you would like to learn more about on our developer forum. And join me at the panel later today. Developer productivity is something I'm very passionate about. We have some really cool industry experts joining us. Hopefully we'll learn a lot in this process. And with that, thank you for your time.
Okay, questions. Please come to the microphones up the front.
Facets, but can you say a few words whether you have this in container form?
Yes. Well, all our software stack is released as Docker container images. You can go to our developer page, easily get it from our it's called the Habana Vault. You'll find a catalog. You can go find the right versions of TensorFlow and PyTorch container images and get started easily.
Thank you.
Hi, I'm Sidnath from NVIDIA Research. Thank you for the talk. I wanted to ask, how does the Gaudi 2 compare with A100 with respect to energy efficiency? I know you showed training time reduces, but what is the energy footprint?
That's a good question. We haven't. I mean, we know we measure the TDP, but that's like measuring it per workload. That's one of the activities we're going to be working on in terms of measuring how much power each workload consumes and actually benchmark energy efficiency. This is a question that's coming up more often these days, especially with sustainability becoming a very important question. So this is something we're working on. We'll have more data to share. I don't have immediately an answer right now, but thank you for the question.
Okay, thank you. And another very short question.
Sure.
What are the next steps? Are the architects of Gaudi 2 looking at sparsification and stuff like that for better?
So we are. I mean, a lot of it is driven by what our customers are asking for. There's obviously innovation that happens in terms of what we think needs but it's driven mostly by what our customers are demanding. So it's not particularly one or the other. So I mentioned FP8 as being one of the things which is now there's traction. We want to see where that goes. That's one of the things we're looking at. if the ecosystem picks it up, that might be a direction. So there are many such vectors, not one or two in particular. Thank you.
Hi, Sree. Thank you for the lovely presentation. As a young startup, let's say if we go to AWS and they offer us this free package, does it include also the DL1? Could we use it within their package? Just a practical question.
Yes, absolutely. Yeah. Like if you are part of the startup program with AWS, you can certainly use DL1 instances for that. It's available. It's an EC2 instance. So whatever you get with other EC2 instances, you get with this, the same DL armies, the DLCs. So you can reach out to them and ask for DL1 instances and reach out to me, and I'd be happy to facilitate the conversation.
Thank you very much for the presentation. Very, very interesting and exciting. Like the gentleman that just asked, we're also a startup. We're working with AWS, and we get to choose what infrastructure options are available. But do you get feedback in terms of what some of the results are in terms of the POCs, or do we have to interact with you directly in order to?
So we do certainly get feedback. Obviously, you would, if you work with AWS, you are an AWS customer, but you do need, support from Habana. We are here, so it's usually a three-way conversation. If you do end up with a situation where you need to work directly with us, they will always provide us feedback on features, capabilities that you would need. So we get constant feedback, and we work directly with our end customers. So both paths are open, actually.
Sorry, Sree, I have a question. So how do you get access to your SDK?
So like I said, it's available on our Habana Vault, which is publicly available. So all these container images are published, and you can do your own installations with bare metal and follow the instructions on our documentation page. It's fairly easy, and that's one of the things in terms of making it super easy to get started without help from Habana.
Okay. Well, there's two sides to easy. One is how to get it. The other is how much do you have to pay to get it. So
it's free, right? The software stack, we don't charge for the software stack. It comes for free. It's basically it's an enabler for you to take advantage of the hardware, right? So we're not charging for the software. It's completely free.
Awesome. So no hurdle to get in.
No hurdle.
And how does the software license work? Are you compatible with open source tools, or how does that?
Good question, actually. So our software stack itself is closed source, the Synapse AI suite, because it's very specific to the Gaudi architecture, and it's optimized. The graph compiler and the runtime and the libraries are specific to Gaudi. But beyond that, above that, we expose APIs that integrate into frameworks, that integrate with all of these ecosystem partners. That's completely open. We invite developers to come and make contributions on GitHub. So we're actually above that level. We want to encourage as much open content as possible, and most of our models are open source. Actually, all of them are open source on GitHub. You can program TPCs. The example is also on GitHub. So awesome. From usage and above, so we don't want the developers to get caught up with how to optimize our software stack, Synapse AI for Gaudi, because that's something that we believe is Habana's responsibility to deliver to you.
Actually, I'm sort of hearing the best of both worlds. You both get to leverage the open source, as well as what you contribute remains within this protected domain. So it's really the best of both worlds for developers.
I hope so.
Awesome. Thanks, Sree.
Thank you so much. I really appreciate the time. Thank you all.